Look at this query. Do you understand what it does? Don't worry if you don't, you're in the right place. This video will teach you a simple technique to understand most complex PromQL queries. That technique is known as vector matching. Don't be afraid. Vector here just means a PromQL data type. An instant vector has a single sample for each result of your query, also known as a time series. A range vector has samples over a time period for each time series. And a scalar is a simple numeric floating point value. To learn more about instant and range vectors, see the link in the description. PromQL is powerful, but when you actually start using it, you realize that it's not trivial. Most tutorials online don't help. They only focus on the high-level basic concepts, like this channel has done up until this point. I'm sure you've tried to use group left or group right and gotten complaints about metric clashes or whatever, but by learning what vectors are, you have taken the first step to grokking PromQL. But what is vector matching? Vector matching simply means how PromQL queries attempt to match elements in the right-hand vector to those on the left. When you write a PromQL query that does an operation on two metrics, like in our initial example, it needs to do vector matching. There are two types of vector matching, one-to-one matching and one-to-many matching. More on that soon. PromQL also has two keywords and two group modifiers for vector matching. The keywords are on and ignoring. They determine how vectors are combined. The group modifiers, on the other hand, enable one-to-many matching. Without a group modifier, the default is a one-to-one matching. But instead of just talking about the operators and modifiers, let's build some intuition using several examples. In this binary operation, we are multiplying a scalar with a vector. To fulfill this query, PromQL will apply the binary operation to every time series in the right-hand side vector. Just remember that the aim of vector matching is to match each element on the left to those on the right, and this will make sense to you. Let's look at a slightly more complex query. We have two vectors that need to be added to each other. In this case, PromQL will look for a single matching element on the right for each element on the left. Matching is done by comparing all the labels. They must have the same names and values. The result here is a new vector containing only two time series, the addition of the vector matches. The time series without a match are dropped from the results. This is an example of one-to-one matching. One element on the left matches a corresponding element on the right. But what if we only want a match based on a specific label? If we only care about the location in the results, we can use the on modifier to reduce the label set. By adding the on modifier with the location label, the result becomes different. The resulting time series drops the color label and every location is represented. Lagos becomes 19, London becomes 18, and New York becomes 27. So we understand one-to-one matching, but what happens in queries that need to do one-to-many matching? And how does this situation arise? Take a look at these vectors. Two time series in this vector have the same color. If we try to match on color, there are two time series on the left, making it a many-to-one matching. By default, Prometheus does not allow this, so it complains with an error you've probably seen before. Thankfully, we can use the group left or group right modifiers to fix this. When we add group left to our query, Prometheus will use the color label to match entries on the right. This gives us a result that has an entry for all the label sets. The same thing applies if we do a group right, but obviously your choice depends on which vector has multiple entries with the same label. Let's look at another example. This time, we want to divide one vector by the other by matching on the location label. What side of this operation is potentially problematic? If you said the right-hand side, you are correct. Our operation only works if we add a group right modifier to the query. Well done on making it this far. The last type of operation should be easy to understand. PromQL also supports logical operations like AND, OR, and UNLESS. These operations will always be one-to-one, so no need to worry about group lefts. The caveat is understanding how the operation works. The AND operator selects a time series from the left with at least one match on the right, while the OR operator attempts to select time series from the left and right. The UNLESS operator, on the other hand, will select time series that do not match anything. As an example, the AND operator between these two vectors selects these entries on the left with matches on the right. Note that the value remains the same. Also see an example of the OR operator. The resulting vector selects elements from the left and missing elements from the right. I hope these simple examples have helped you develop better intuition about about more advanced PromQL queries. Remember the query you saw at the beginning of this video? I encourage you to go back and try to describe how Prometheus will handle it. If you post what you think will happen in the comments, I would also let you know if you are wrong. And for more videos like this, please subscribe to the channel.